Thanks for joining us for this session, probably the second last session of the day, so appreciate you making the time. Our session topic is what's the Hadoop-la about Kubernetes? Just quick introductions. I'm Anant Chintamaneni. I'm responsible for product at BlueData. We're an infrastructure software company. We have a booth here in the conference, so definitely join us when you have a chance. And then I'm joined by Nanda Vijaydev, who heads up solutions for BlueData and works very closely with our engineering team, who is also, working very closely on Kubernetes. So today we have a fairly straightforward agenda in terms of some of the market dynamics we're seeing with respect to containers. Obviously, it's containerization is a pretty hot topic, and that's kind of these days containerization is sort of Kubernetes is synonymous with containers. So we'll talk a little bit about the market dynamics, what we're hearing from the customers, and which includes many of you, and then go into Kubernetes. What is Kubernetes? Why should you care? I'm sure a lot of you have some basic understanding of Kubernetes. Just curious, by show of hands, how many of you have been doing something with Kubernetes, or at least have some familiarity with Kubernetes? All right, that's quite a few. So I guess I could blaze through some of the sections that I have on Kubernetes just to sort of same page on the topic. So we'll talk about that, and we'll talk about why you should care. And then we'll switch into some of the requirements for running Hadoop clusters on Kubernetes. So that's, we'll sort of outline those requirements. And then I'll hand it over to Nanda after sort of outlining some of the key gaps that we see in Kubernetes as it pertains to running, full-fledged Hadoop clusters. And then a lot of the detail that we'll have in the presentation will be about how to address those gaps, or at least our view on what needs to happen to address those gaps to be able to take Hadoop and run it on Kubernetes so that you can get it to a point where it's native, it can be production scale. And then we'll have Q&A. So with that, I'll jump into it really quickly. The promised land. So we talk to a lot of customers, and what they're looking for, and what we hear, and this is our interpretation, is they have on-prem infrastructure, they have a desire to go to the cloud, or they're already in the cloud. So they have a combination of on-prem infrastructure and public cloud infrastructure. They want a single platform. Initially it was all about, folks calling them, having a cloud platform or what have you. But really what they describe to us is they want a single container platform, very specific about using containers, a single container platform for running multiple application patterns. And they want this to be, obviously infrastructure agnostic. They want to take this cloud, run it on premises, run it on the public cloud providers. They want to have a single container platform to run their stateless applications, which include your mobile, your web front ends, your mobile back ends, stateless services. We'll go into this in a little bit more detail. Their stateful services, obviously they want to run, databases. Those are, very important workload in any enterprise. So they want to run databases, their queues, and so on. So these are more stateful, and we'll go into this in a little bit more detail. Daemons, log collection, monitoring, and anything else that you can think of. And in that anything else that you can think of, one of the key requirements that we hear is, hey, we want to run our Hadoop clusters, our Spark clusters, and not just any old Hadoop cluster, their specific tailored version of Hadoop or Spark or any other sort of distributed application framework on containers. And that's kind of where they want to be. They want to have a single cloud platform, and they want to be able to run these different workloads. And there's been a lot of this discussion. We've been on this journey with containers for over 4 years now. Kubernetes came into the play right about 2014. There were obviously other players like Docker. Docker had its own container orchestration. But over the last 3 to 4 months, I think it's pretty clear that the winner for that single container platform, whether it is what we see from the press or what we hear from our customers and the market, and you guys can probably validate this, is that Kubernetes is essentially the container management platform that folks want to use. And it's by far in a way. Like any conversation that I have as a product manager with customers, with partners, they're thinking about Kubernetes. And obviously every cloud provider today offers a Kubernetes service. Even Docker has embraced Kubernetes now. And there are others who've embraced Kubernetes. So that's just a quick point there. So what is Kubernetes? And I just want to kind of go into this, not too much detail because I want to leave time for talking a little bit more about running Hadoop on Kubernetes. But essentially, there are some interesting things to take away from it. It is an open source platform. It is an open source container orchestration engine that allows you to run multiple different applications in containers. It does the management. It was developed by Google. It's a very, very sophisticated, very carefully thought out platform. And it is the platform for running containerized workloads. So basically, in a nutshell, it spins up containers, clusters of containers, manages them, and it gives you the ability to describe what the end state for that cluster of containers should be, and gives you a set of mechanisms by which you can maintain that desired end state of containers. The important point here is that it's a platform building block versus a turnkey platform. I think this is a very important aspect. Kubernetes is not a product. It's not a like a turnkey platform that will give you storage, networking, an inbuilt queue, database, monitoring, management. That's what we're all used to thinking about when we go and look in the market for buying a platform. A lot of things are provided for you. Kubernetes is really trying to develop an ecosystem. They've left a lot of, it's a very pluggable platform. They're expecting you to bring your storage plugin, your networking plugin, your own monitoring solution, and so on. So that's why I think it's important. They also describe this very carefully on their documentation site on what Kubernetes is not. The top use case and some of the genesis for why Kubernetes came up was to run stateless or microservices, just a fleet of containers, each running its own service, each running the same service, and really availability was the key idea, to be able to scale up and scale down those containers based on the load. It is evolving for stateful workloads, and when I say stateful, I'm talking about databases, Zookeeper, Hadoop. We'll get there. So it's a very confusing space. I have to tell you all, like when you go talk to a lot of people, they think Kubernetes can solve any kind of problem. It's got all the capabilities you can possibly imagine, but the reality is it doesn't. It requires you to make some careful choices, design choices, to be able to use it and apply it for your specific workload. So some of the key concepts, right? So I already talked about Kubernetes being a platform for application patterns, and the goal of Kubernetes is to run any application, whether it is stateless, stateful, Hadoop. Think about anything, you should be able to run it. The next important concept is a pod. A pod is essentially the simplest, the lowest sort of level object in the overall Kubernetes object model. And a pod can consist of multiple containers. And the way Kubernetes is designed, the pod is essentially where you would be running your process. And then there is a very important concept called controller. Now, Kubernetes offers a set of controllers. And the whole purpose of the controller is to make sure that your cluster of containers are able to maintain a specific end state, right? So the controllers can, there are many controllers, and they'll act on your cluster of pods to ensure that whatever description you had for this, let's say, very simple, I want to have 10 pods running. And that's, they have a replica set and a controller that takes care of maintaining that there are 10 pods. So we'll go into this in a little bit more detail, but there's a set of controllers. And it's very important to think about these controllers, because when Nanda talks about what you need to do for Hadoop, we're going to talk about this concept. So just high level, I'm trying to keep it as simple as possible. So Kubernetes follows a master worker architecture. It's got a master node. It has a set of controllers that run on that master node that just make sure, like any other sort of distributed system, it schedules stuff onto the worker nodes. It can monitor and manage what's happening on the worker nodes. Very standard sort of distributed type of architecture. The actual containers, or the pods, as it's called in Kubernetes, are scheduled on the worker nodes. And like I said, each pod can be a set of containers. And the worker nodes themselves have an agent running that sort of ensures that the pods that are scheduled on its node are up and running, and then also obviously communicates with the master node. The controllers, as I mentioned, Kubernetes provides 3 or 4 controllers. I'll go into that in a short sort of detail here. The controllers themselves act on the pods and make sure that the pods are in the desired end state that you want them to be in, based on whatever manifest that you've described. And then the pods themselves, they have like internal IP addresses, but the pods are more mortal. I mean, they can come and go, and their internal IP addresses might change. So there has to be a way to communicate with these pods. So Kubernetes, again, has an abstraction there. The abstraction is called a service. So you never talk to the pod and the containers directly through the IP address, but you talk to the pods through a service. And this is, again, a very important concept. And the reason why I bring this up is when you think about Hadoop and Spark and some of these clustered products themselves that run multiple services that need to communicate with each other, you need to be able to think about and map it to those type of concepts to be able to have inter-service communications. The service is another important concept. The next sort of set of concepts are, so I think we summarize what Kubernetes at a high level is. Storage is obviously a huge and very important one, especially for many of us who are in the Hadoop space. So Kubernetes, from a storage perspective for these pods, have the concept of volumes. So pod has, out of the box, it has a volume, but it's ephemeral. So if the pod gets destroyed, then the volume goes with it. So obviously, you're not going to be able to store data. Volumes are not going to be really useful for stateful applications. So that's where they have a concept of a persistent volume, which is essentially networked storage. It's pod independent. So you could be using, and there's a number of storage plugins out there. There's a plugin for Ceph. There's a plugin for Scale.io. There's plugins for NFS, Gluster. It's your choice. As when you put up your Kubernetes deployment, you have to make that choice of what storage plugin you're going to use. And then, essentially, then you can create these definitions. Persistent volume claim is another concept, which is where you make your definition of how much you want from a storage perspective, and the persistent volume, and will basically make sure that you get that much storage for your particular container that you're bringing up. So the controller patterns that I talked about. Again, one of the key reasons why I want to go through some of these controller patterns is this is kind of how you onboard the different applications on top of Kubernetes. So Kubernetes offers, this is by no means comprehensive, but these are 4 popular controller patterns. The first one is for stateless application. It's called a deployment controller. You basically define how many pods you want to have running, and it's all about availability in that particular case. And Kubernetes will ensure, this particular controller will ensure that the set number of pods that you've defined in that in your definition are maintained. So Kubernetes, this particular deployment controller will take care of that. And then obviously, you can version them, you can upgrade those deployment controllers to change it from, let's say you had initially 10 pods to maintain to 12. Again, that's a controller pattern. The next one, which is stateful, it's a very recent one that's been in the works. It's gone through a few evolutions. It used to be called pet sets, then became stateful sets, and it's GA as of Kubernetes 1.9, which is a fairly recent release. And stateful sets are really intended for running your databases, like your MongoDB, even your Zookeeper, MySQL. It's focused on consistency, and the stateful set controller pattern basically ensures that for any kind of service that has some ordering requirements, For example, if your pod goes down and comes back up, you want to make sure that the storage that's associated with that pod is the same storage that you had before it was destroyed. Otherwise, your application is going to be rendered useless. So that's the stateful set controller. Then there's a daemon set, which is essentially one per node, or one per Kubernetes node, or you can sort of define which nodes should have it. So for example, if you have a monitoring service that needs to be running every time a Kubernetes node is added into your Kubernetes cluster, you can ensure that you have a daemon set. So Fluentd is an example of one that could be run on each of the nodes. And similarly, there's a pattern for jobs. So if you wanted to have a set of pods come up, maybe do a specific task and then go away, then there's a job controller pattern. The key takeaway for the reason why I'm introducing these controller patterns is that if you want to run a Hadoop cluster on top of Kubernetes, you will need to think about either using a combination of these types of controller patterns or a controller pattern like one of these available. Clearly, what we'll see is that none of these controller patterns by themselves will satisfy the need for running a full-fledged Hadoop cluster. But anyways, this is good. So controller patterns, hopefully, I really want to drill that home because we're going to be talking about that some more in short order. Just a quick reality check here. I think Kubernetes, as I said, is evolving very quickly. We personally are very excited about what's happening there and some of the work we're doing with Kubernetes. This is from the CNCF. So Kubernetes was started by Google and now is part and is managed by the Cloud Native Computing Foundation. And this is by no means comprehensive, but these are some of the topics that folks are concerned about in terms of when they onboard Kubernetes into their environments. Some of the biggest challenges are around security, networking, storage. Storage is a big one. I'll keep hammering that home because when we think about running data-intensive type of workloads like Hadoop, storage is key. And as we all know, with Hadoop, the data locality concept is sometimes near and dear. The ability to store petabytes and operate on petabytes of data, terabytes of data is very important. So storage is obviously important. Networking is also very important. You run multiple services. So there are areas that I think are still big challenges for folks out there. And I think as the size of the company goes up, these challenges become even more. Security is one that I'm sure all of you, whether you're at each of your companies, it's a top of mind item, and especially as it pertains to Hadoop, there's a lot of considerations around security, Kerberos, integration with Active Directory, and so on. So that's just sort of Kubernetes in a nutshell. Remember the controller patterns. All right, so let's speed up here a little bit. So why Hadoop and Spark on containers? I think there's two sides of the house. If you talk to the folks who take care of the infrastructure side of the house, the servers, the storage, networking, and so on, containers are essentially like lightweight virtual machines. They obviously don't have that kind of baggage that virtual machines bring. They deliver elasticity and agility. You can spin up a bunch of containers very quickly. You can scale them down, scale them up. You can get standardized environments by using the concept of like Docker images. You can make sure that you can get reproducible environments because you can put everything into the Docker image. So whether it's dev, test, prod from an SDLC standpoint, it's quick to spin up environments that are standard. You know what went into them. Portability, this one's a big one. Customers are looking at containers and therefore Kubernetes as a way to get that abstraction and that portability from developing an application on-prem, moving it to the cloud, or running it on the cloud, moving it back, or even a multi-cloud type of strategy, because you can run containers in VMs, no problem, right? And the resource utilization story is always there. That's what kind of made VMs very, very useful. Was hey, we can take one physical server, really over-provision the CPU, and fit like 7 or 8 containers on top of it. So what you could do with what you needed 80 servers for, you could do with 10 servers. And on the other side of the house, we're in the age of AI, ML, data scientists. Obviously there's a lot of libraries and applications that are being used. So containers offer a foolproof way of packaging all those configs, libraries, and I think there were some announcements today as well where Hortonworks now with 3.0 is supporting, taking applications, using them, putting them in a Docker image and running it in Yarn. And repeatable builds and orchestration, those are all the usual benefits of containers. And we do believe fundamentally, and customers are seeing that you can get agility and faster speed to market with containers. So when we say why Hadoop and Spark on containers and Hadoop and Spark on containers, this should not be confused with what I just said earlier around, this is not about using Docker containers to run Hadoop or Spark tasks on Yarn. That was the announcement that was made today. What we're talking about is running Hadoop clusters in containers. So spinning up a set of 10, 15, 20, 100 containers and running a Hadoop cluster on top of those containers where each container acts like a lightweight VM. So what we're talking about here is, if you're a resource manager, that's running, in a container. This is your master node, your worker nodes running node manager. Each of these blue boxes here are containers. And then having, one cluster, so a cluster of Docker containers. So we all know, to set the stage for what are some of the key considerations as you think about running Hadoop on a cluster of containers that are spun up by Kubernetes. We have to think about Hadoop clusters as they're today. They're not exactly monolithic, but they're pretty close. They have multiple cooperating services with dynamic APIs. There's very specific ways by which you would start up services, other dependent services needed to start up. And there's a lot of service interdependencies. And all of you here in the Hadoop conference know about some of that, and I'll highlight some of those sort of dependencies. And there's a lot of configuration in Hadoop clusters. There is configuration for your the manager that you're using, whether it's something like Ambari. You've got Hive Server 2, which is backed by a database. You've got pretty much, you can come up with many services that each are maintaining state. There's host names, there's serious dependencies on FQDN, stability of having that FQDN, IP addresses, ports. There's just a lot of configuration and metadata in these clusters. And not to belabor the point, but Hadoop itself is a clustered product. It's, if I talked about Kubernetes being a clustered product, Hadoop itself is got clustering. It's got a high availability scheme. There's a lot of different services here. I mean, this is just again trying to emphasize the fact that Hadoop is complex, and there's a lot of services to keep in sync. There's your Yarn services, your HDFS services, then there's your management services like Ambari, your MySQLs, and so on. And then new stuff keeps getting added. And last but not the least, it's not just about running Apache Hadoop cluster. You could go take Apache Hadoop and containerize the node manager, containerize the resource manager, and run a bare bones kind of Hadoop cluster, maybe a name node, data node service. When we're talking about running Hadoop on Kubernetes, especially in the context of large enterprises, they have standardized on specific distributions. So each of these distributions has a very specific way by which those clusters should be run. So if it's Hortonworks, you want to use Ambari, right? And you have to use that common deployment pattern so that you get that sort of supportability. So these cluster managers themselves are quite complicated. So you have to think about that. And then, it's not just about running one Hadoop cluster. The reason why customers want to have this common container platform, as you see here in this particular diagram, is they want to run multiple different Hadoop clusters, workload-specific Hadoop, Spark, AI, ML, those types of clusters. We're talking about Hadoop in this case. Somebody wants to run data engineering workloads that are more Spark, MapReduce, Hive intensive. There's folks who want to run SQL analytics clusters. There might be Spark SQL, Presto, Hive with LLAP, whatever might be the case there. So there's multiple different Hadoop clusters that need to be run. So your orchestration, when we think about it, is not just about bringing up one cluster on a set of containers, but how do you make that repeatable? How do you manage the life cycle? So really, the requirements for success to make Hadoop run on Kubernetes are as follows. Hadoop won't change. Hadoop is very, very, it can change if Hortonworks and the community decided that it's time to go and rewrite Hadoop to be a complete microservice-oriented architecture. Sure, but that's not happening anytime soon. So we have to think about how do you take Hadoop clusters the way you run them on physical servers or virtual machines and run them on top of Kubernetes. Resource management is still going to be done by Jan. When you go and submit jobs into a Hadoop cluster, the queues, the resource management within that Hadoop cluster, even though it might be running on containers, will still be managed by Jan. And that's an important point. Your master services have to be always running. It's not like your stateless applications where you can have a set of services come up. You may have 10, 100, 1,000, and then you can just scale them down. They're not dependent on each other. You have to have your master services running. If you don't, your Hadoop cluster is gone. So with that, I'm going to go ahead and hand over to Nanda, and who will talk about some of the gaps that exist today based on some of the requirements that I outlined. So first and foremost, the available controller pattern is insufficient. The K8s services, running them is not trivial. And then, the persistent volumes and persistent volume claims need to adapt to the Hadoop requirements. So with that, is it possible to run Hadoop in all its glory on Kubernetes? I kind of dampened the mood a little bit, so hopefully let's see what we can do here.
Hey, thanks, Anant. We have 10 minutes, okay?
So, that's fine.
Yeah, there is quite a bit to cover, so I'll keep it very high level, and whoever has questions after this can please come and talk to us, and we'll be around. So the answer to this question is yes, but it needs a lot of work. Right? So I'll just walk through, we have made it work, and what were the lessons learned, and what we're doing now to make it more compatible with the native Kubernetes type of deployment. So is it moving forward? Okay, so it's a journey, right? For those who have started working on Kubernetes deployments, even stateless is, it takes some time for you to build the whole ecosystem. And then considering Hadoop, why do we know this? Is we've been deploying Hadoop on containers, as Anant mentioned, for about 4 years. And Kubernetes way of deploying is, in the last 1 year, we've started working on that. We've had our own orchestration because of what Hadoop is, what it takes to run Hadoop on containers. So there's a lot of lessons learned when we built our own custom controller. And then a lot of those patterns were reusable. And at the same time, the Kubernetes community is also doing a lot of work. So we wanted to make sure that we take our lessons learned and also use what's happening in the Kubernetes community and see how we can bridge the gap and what else is left to do. Right? So the custom controller that we built, but a very high level, this was done 12 months ago. The controller itself was running as a pod, and you had your default namespace, and then within the BlueData namespace, we were able to bring up additional Hadoop clusters or Spark clusters or whatever customers requested, all running on Kubernetes. But kind of going a level down, getting deeper into this, what was the goal of our approach, right? We wanted to run Hadoop unmodified. As Anant mentioned, Hadoop is not a microservice. So we wanted to make sure we run Hadoop unmodified. That means we had to launch stateful sets. We weren't looking at Hadoop as a set of individual services, but as nodes that were running set of services. You could have multiple services running on a single node. And when you start configuring in Hadoop, name node, your HDFS should come first. Then probably your Yarn resource manager. And then you have your Hive server 2 or whatever. So there is a sequence because it is not just about running one stateful set. It is about running interdependent stateful sets. Right? So that is one of the key goals. And then it is about a lot of those services have to be accessible by end users. Your Hive Server 2 is a persistent service that has to be accessible by outsiders. HDFS. Similarly, it is not about making sure that there is one service that's exposed and load balanced, but it is a number of services that are interdependent and also running as its own standalone service for end users to access. And Hadoop in an enterprise is not just about a set of services. Now you have Kerberos enablement, SSH enabling of endpoints. There is a lot of different things that you have to consider when you run it in a real enterprise and when you get out of your experiment or the POC mode. And then the performance goals, right? There are some implications, and we had addressed some of these with compute storage separation. We don't want to get into that, but this is, we will talk about how a controller pattern addressed that. So at a high level, to give you a very visual indication of what was happening with this controller pattern, the requests were made to a BlueData UI or BlueData API. So at that point is significant because then we'll get into what we're doing now, which will eliminate you from getting to a specific controller and actually use more native way of accessing services. Right? From an end user, they could submit through a UI or an API, which didn't go directly to the Kubernetes API server. But BlueData was able to take this and behind the scenes create its own manifest file or create its own resource request file and launch requesting of stateful sets or launch requesting of persistent volume claims and all that. And in terms of node, as you can see here, we don't refer to it as a service because it is not just about one service running on a particular pod. It is about many services running on a pod because that's how Hadoop truly works. It is not, it's not a microservice to the point we spoke about before. Right? In here, again, each one mapped to a node, which is equivalent to a physical VM and not really a pod. And when you talk about workers, arbiters, these are all different stateful sets and number of services on each of those stateful sets. Right? So after you deploy a full Hadoop cluster, you can see that each one of this is a container with a persistent IP address, which means you can actually access SSH into it and then do your necessary configurations if you have to. And then there are many endpoints that are clickable or that are accessible between the services. And for each one of that, from a Kubernetes concept perspective, we ran a node port service at the pod level, and this node port service made sure that all the different services inside Kubernetes or inside each one of those pods was exposed to the end user. Again, there are some new concepts here, so if anyone is not familiar, we'll always stick around and talk to you guys. So going a level deeper, the definition of stateful set is still very confusing for people. Is it just about persistent volume or is there more? Right? So the first thing is, of course, you need persistent storage. And when people talked about persistent storage, it was all about data, persisting data. But then there is your root volume where if you don't change the way applications are deployed, your log files could go to /var. Your configurations could go to /etc. Your binaries are in /opt. So how many of those do you want to preserve is really where we made sure that we did some work in the init containers to make sure even those were mapped. So if there is a crash or if there's a migration, you can preserve that and keep the state as is, right? And accessing the container to run some agents because these agents internally did a lot of work. And I'm going to move forward because So the key gaps, there were gaps, of course, with what we did. It is because BlueData was the front, the authentication and authorization was done by BlueData controller and not by Kubernetes. And it was limited to the namespace where BlueData pod was running. And from a usability perspective, people are used to running kubectl commands or running their Helm charts, and they weren't able to do that because we weren't exactly supporting kubectl in that way. So really where we are headed or what is next is the exciting part for us is for standard, keeping it as native as possible to Kubernetes, right? So your standard, if you want to create a pod, or if you want to get services, you're all launching kubectl commands, or if there's a little bit of more complicated dependency management, you're using Helm charts, And the concept of operators is becoming more popular now. There is a Spark operator, there is a Kafka operator, and really what we are working on is a more generic, especially for Hadoop, a more Hadoop operator that lets you deploy Hadoop in a native methodology of Kubernetes. And what that takes behind the scene is really, when there are default objects that are understood by Kubernetes, when you say pod, it is understood. Your storage class is understood. But when you say Hadoop, it is not an object that Kubernetes understands. So that's where it gives you that ability to extend with custom resource definitions or custom controllers, which together is the operator. And that's the work we are doing. And I'll see if I can get through this. If not, like I said, we can always share with you guys later. So in a nutshell, what happens really is that you have your native world of Kubernetes, and then you register a custom object. This is giving you an API extension. This API extension allows you to use more things like, create a Hadoop cluster for me, or give me Hadoop cluster object your native controller does not understand. And this is really where you need your own custom controller built in. The beauty of this custom controller is you can do whatever you want with it. You can just define what type of objects you want to create with your CRD registration, but then your custom controller is the one which is really doing all the work. Without a custom controller, you can still register, but when you get a request to create such an object or do something with it, other than registering it in etcd, the etcd understands, but no one else is really operating on that because none of the native controllers really know what to do with it. So that's really where this whole thing is the operator, both together. And when you actually call a real endpoint API with this type of object is when you actually start doing the work. Right? There are watch events. There's more understanding the desired end state. There's a reconciliation loop. There is a lot of things that happen in the controller, which is what is acting. And now it is deploying the stateful sets and is deploying Hadoop, configuring Hadoop, and doing all the work that needs to be done. So this is not just about creating. If you scale up, if you scale down, all those are events that are not natively understood by default controller. And now all those events will be watched by your custom controller. And that is the one that's going to do all the work. So I'm going to skip through what is the definition of a CRD. You guys can get that. But it's really to the point where it acts like it is a native Hadoop. It's a native Kubernetes API, but it is not. But you can still talk to your API server, which is doing all the service. But all the commands are being handled by your custom object. Right? So you understand the kind. There are all kinds of objects that you can define. Your custom resource is defined using the kind custom resource definition. And just the last one, where Hadoop cluster, when you create a new object, you will say, I want to create an object of the type Hadoop cluster. And then the controller takes over and does the things that it needs to do on that new object. And the beauty of this is you use the standard kubectl commands. And the API endpoints, now you have a group API endpoint. And this will be specific to the custom object that you define. And you can create it dynamically, remove it. And your native Kubernetes is not affected in any way. This is serviced by what you've added now. Right? And this is how you add a new object. As you, in the previous slide, we showed that it creates its own endpoint. With its endpoint and of the type Hadoop cluster, now your specification is completely yours. It doesn't have to stick to the terms that Kubernetes understands. As long as your controller can handle whatever is in your specification, you will be able to act on this. So really at a high level, this controller is really the most complex thing, right? This is what we are in the process of building. This controller is where if you want to create a Hadoop cluster, if you want to create specific applications, if you want to create multiple clusters, if you want to start services, these are all the sequence of things that you have to do. So this controller has to understand the sequence in which you create, you operate, and then you enable all the expand, shrink type of applications. So, if you review now, if you go back to the controller with the definition, you will see that a lot of work is actually done within the controller, just using the constructs of Kubernetes. And in addition, you can actually have the controller do your AD integration, enabling your Kerberos, and all the other security setup that has to be done. Right? With the lessons learned, we had gotten the networking part figured out. Our custom controller that we built, revision 1, the networking was fine. The option we used was Calico. We can plug into whichever the deployment is given. Same with the storage. And this approach will work on any standard Kubernetes installation 1.9 or higher because of the dependencies with stateful sets and all that. So really the key takeaway is Kubernetes is still, a lot of documentation is still suitable for stateless services. And how do you replicate, how do you load balance? It's all about stateless services. And running complex distribution, you can still use Kubernetes, and the benefits of having a single monitoring, single resource management is still very useful. But you will have to do some work with your own controller patterns to make sure that you understand how this works, right? And I guess it stopped.
All right, go forward.
Okay, stateful sets it's a good enabler, but it's still not there. There are, like as we mentioned, there are still things that needs to happen. And the most confusing part is there are multiple community projects that are happening. It is trying to figure out which one is the right fit for what you want to do will require significant amount of time to make sure you reach your end goal. All right, so this is really what we are working on, and keeping time in mind, we just wanted to finish it on time. And like I said, we will stay here and answer any of your questions. And if you guys have any Q&A. Or we also have a booth if you guys want to stop by.
Thank you all for your time.